Okay, this is lesson 23 for 8th grade, and today we're going to talk about multiplying and dividing mixed numbers. So yesterday we talked about multiplying and dividing fractions. This is not much different. There's just a little change that one extra step we're going to have to do today. And here are our goals first. We're going to review how to turn mixed numbers into improper fractions. This is the extra step we have to take. We're going to take our mixed numbers and turn them improper. And then we're going to use our multiplying and dividing skills for fractions after that. So this second step, this is everything we talked about yesterday. We're just adding one other step, mixed number to improper fraction, and things should go pretty smoothly. All right, here are our steps. As I just said, first thing we're going to want to do, turn the mixed numbers into improper fractions. And then we're going to multiply or divide fractions. Now we want to remember, big thing here, if we're dividing, we end up multiplying by the reciprocal of the second fraction. So we turn our division of fractions into multiplication after we do the reciprocal. And lastly, we're going to reduce or turn into a mixed number. So we'll reduce regular fractions. If we have an improper, we're going to turn it to a mixed number. So let's first of all look at these two examples here. So remember, our first step said that we're going to turn everything improper. Remember, to turn something improper, we go denominator times our larger number, 3 times 2, then we add the numerator. So 3 times 2 is 6, plus 1 is 7, and we keep the same denominator. Okay? Times 2 times 1 is 2, plus 1 is 3, over 2. Now we could multiply straight across if we wanted to. 7 times 3 is 21, 3 times 6 is 6, and then we could reduce after that. But I'm going to take that shortcut that we were talking about yesterday, and I see diagonally here, we've got a 3 and a 3, one's on top, one's on bottom. That means we can cancel before we multiply. So 3 and 3, 1 and 1 right there. Okay? That's because 3 divided by 3 is 1, 3 divided by 3 is 1. 7 and 2, they're both prime. They don't share any common factors. So now what we have is 7 times 1 is 7, and 1 times 2 is 2. Now we could turn this into a mixed number. So right now this is improper. I know that 3 2's go into 7. So we've got 3, and we've got 1 left over. 3 and 1/2. 3 1/2 there. Now we can check to see if that's right, just to turn this back to an improper and see if we get this. 2 times 3 is 6, plus 1 is 7, 7 over 2, boom, we got it, alright? So that's how we turn it into a mixed number at the end. That would be a review type thing. One other way you can do that, actually do the division. So 2 and 7. 2 goes in here 3 times. 3 times 2 is 6, minus 1. You get a remainder of 1. If you just put your remainder over your divisor, you'll get the right answer. So 3 and 1 over 2. Basically what we got right there. So that's how you can do it if you don't want to do it in your head. Alright, let's look at letter B here. First thing we're going to do, turn everything improper. 3 times 1 is 3, plus 2 is 5, so we have 5 over 3, divided by 2 times 2 is 4, plus 1 is 5, 5/2. Now we're dividing, so we have to remember to reciprocal, reciprocal, reciprocal. We're going to reciprocate. I think Jordana came up with that one, if I remember right. I'm not sure, but I thought it was a cool word, so we're going to use it. Alright, so 5/3 times 2 over 5. a multiplication problem now after we reciprocated our second fraction there. So, we can do some canceling. We got a 5 and a 5, 1, 1. 3 times 1 is 3. 1 times 2 is 2. Alright? Yep, that looks pretty good. Alright. Make sure if I make a mistake that you catch me on it. I'm going to try my best not to do that, but let me know. Math teachers are human too. We make mistakes sometimes. Rarely, of course. Alright. Here's a good word problem to look at for dividing with I think it's a division problem. Let's look at it. A carpenter is nailing horizontal boards to the outside surface of a building. The exposed portion of each board is 6 3/4 inches. How many rows of boards are needed to reach the top of an 8-foot wall? So, if we're looking at our 8-foot wall here, we've got these boards that are 6 3/4 inches. How many boards are we going to need to stack up to reach our 8 feet? This is a classic division problem. We want to see how many of these fit into 8 feet. Now our big problem right away is that we need to get into the right units. We have 8 feet and we have 6 3/4 inches. So we want to get everything into the correct and same units. So what I'd recommend is turning 8 feet into inches, because turning this into feet is not as easy. So we know that there are 12 inches in a foot. So 12 times 8 should give us our answer for how many inches we have there. 8 times 2, 16, carry our 1. 8 times 1 plus 1 is 9. So this is 96 inches. Alright. Now we want to see how many of these fit in to 96. So I'll erase this here. So basically what we have is 96 divided by 6 3/4. Alright, now we want to change everything improper. So, to change this to an improper, I just go 96 over 1 divided by 4 times 6 is 24, plus 3 is 27, all over 4. And we want to reciprocate, or get the reciprocal of our second one there. So this is actually 96 over 1 times 4 over 27. Alright. So we're going to want to figure out what goes into, well, it looks like 27 and 96, they share a common factor. I think it's 3 that they share. So if I divide this one by 3, I get 9. If I divide 96 by 3, not sure off the top of my head here. 3, 32. That should have been something I could have done in my head. Anyway, 32. So 4 times 32 is 128 over 9. 1 times 9. And I'm going to erase some things again here. We want to turn that into a mixed number. And I want to make sure we're on the right track here. Okay, looks like we're good. We're going to actually want to divide that 9, 128. 9 goes into 12 once. Times 9. Minus 9, we get 3. Drop down our 8 here. 38. 9 goes into 38 4 times. 4 times 9 is 36. Subtract, we get 2. So we get this is our answer, but it says, well, that's our exact answer, but it asks us how many rows of boards are needed to reach to the top of an 8-foot wall. Well, we need 14 2/9 of them. 2/9 is a fraction, so we need at least 15. So 15 boards to reach the top there. That one had quite a bit to it. Alright, see if we have anything else here. This is just our summary here. Might be a good thing to have in your notes. Alright, multiplying and dividing fractions and mixed numbers. First, write the whole number, numbers or mixed numbers as fractions. If you're multiplying, multiply numerators, multiply denominators. Remember, you can also cancel before doing any of that. And then you're going to simplify by reducing or representing it as a whole or a mixed number. The only difference with dividing, instead of dividing, multiply by the reciprocal of the divisor. That's our second one. Alright, we will go over some of this stuff in class, and we'll continue with our other lesson tomorrow.